So we're in the last lecture of chapter 4, and then we're moving on to chapter 5 after this. So I am on page 27 in the blue pages of the student note packet. I'm going to go through one of the examples at the top, and then you'll do the other two on your own, and then we'll start with that rational function example on page 27 today. So just a quick review of vertex form of the equation of a parabola, because you guys are going to be graphing quadratic asymptotes in just a minute, and it's always easier if we can write that equation in vertex form so that we can graph it a little bit easier. So in the case of number 1 here, to get it into vertex form, we're going to move everything with an x to one side, everything without an x to the other. So I'm going to subtract 7 from both sides. And then I'm just going to check to make sure that the coefficient of x squared is 1. In this case it is, so we're good to go. If it wasn't 1, we would need to factor out whatever coefficient that was before we start completing the square. So next step then is to complete the square. What am I going to add here in order to make that right-hand side a perfect square? Well, I'm going to take the value of b divided by 2 and square it. So in this case, in order to complete the square, we're going to add 4 to both sides. Remember that we need to keep the equation balanced. So if I do one thing to one side, I've got to do exactly the same thing to the other. And then I can go ahead and factor the right-hand side into a perfect square here. So the equation in vertex form is y minus 3 is equal to x plus 2 squared. And our vertex here is just negative 2, positive 3. Okay, with a stretch of 1 if we were going to go about graphing this. So just finish up 2 and 3, and then we're going to get down to the next piece, which is actually that rational function with a quadratic asymptote. So I'm going to do the work first, and then I'll put everything into the template, and then we'll graph. So we've got this function, x cubed plus 2x squared times x squared minus 4 over x squared minus 3x plus 2 times x plus 3. And this is going to look like something you guys are going to see on your test for sure. So it will be this level of difficulty, especially when we get to that non-vertical asymptote. All right, first thing we always have to do though is check to see if there are factors in the top and the bottom that cancel to create holes. And then once we've got those factors canceled out, we can use a simplified function for everything else. So I'm going to factor the top. I can pull an x squared out of the first term. That leaves me with x plus 2. And then x squared minus 4 is the difference of two squares, which factors into x minus 2 times x plus 2. And then on the bottom, x squared minus 3x plus 2, that's going to be x minus 2 times x minus 1, and then that x plus 3. Okay, looking for things that we can cancel on the top and the bottom here. Looks like I can cancel an x minus 2 on the top and the bottom. And that will leave us with x squared times x plus 2 squared over x minus 1 times x plus 3. And I like to write it in simplified form like that because that helps us with the sign chart in a little bit. Okay, so we do have a hole. That's the first piece of information that I found. We have a hole when x is equal to positive 2. We set that factor that we crossed out in the top and the bottom equal to 0, solve for x. We have a hole then when x is positive 2. Now what we have to do is we have to find the y value. And the y value of that hole is going to be when we plug in 2 to the simplified function and evaluate. So that'll be 2 squared times 2 plus 2 squared over 2 minus 1 times 2 plus 3. That looks like 4 times 4 squared over 5, which is going to be 64 over 5. And I'm just going to leave it like that. So our hole has the coordinates 2, 64 over 5. And we'll just do our best to estimate where that hole is going to be on our graph. All right, next up then, we've got the zeros. Now we're using the simplified function. We're using the function without the x minus 2 on the top and the bottom. There are 2 zeros here. When x is 0, that comes from the x squared factor. And then negative 2, 0 is our second 0, and that comes from the x plus 2 factor in the numerator. Now I'm going to put a star next to both of these because both of these are double zeros. They're double zeros because both of the factors in the numerator were being raised to an even power. So I'm just going to make a note there that's going to help us for the sign chart in a little bit. All right, vertical asymptotes come from the factors in the denominator. We've got 2, x is equal to 1, and x is equal to negative 3. We always make sure that we include vertical asymptotes as equations because they are equations of vertical lines. Neither of those two factors in the denominator are being raised to an even power, so those are not double vertical asymptotes, which means the sign chart will alternate signs around each of those values. All right, next is the y-intercept. When x is 0, y happens to be 0. We have that as a 0 as well. So anytime you see the origin as a 0, that should also be your y-intercept. And then the sign chart, I'm going to come back to. We'll do that on the graphing section where I can actually fill out the template. So let's get into that non-vertical asymptote, intersection, and then the end behavior pieces. And then we'll copy all of this over to the actual template and finish the sign chart before we graph. Okay, so next up, we've got to do the long division here, which means I'm going to actually FOIL everything in the numerator and denominator so I can get something to divide. So this is going to become x squared times x squared plus 4x plus 4 in the numerator, and the denominator is x squared minus 2x minus 3. Sorry, there should be plus 2x minus 3. And then I'm going to distribute that x squared. So we get x to the 4th plus 4x cubed plus 4x squared. And then that is all over x squared plus 2x minus 3. Okay, so long division here. I'm going to do this in a different color. X squared plus 2x minus 3 goes on the outside. X to the 4th plus 4x cubed plus 4x squared goes on the inside. And we start. So what do we multiply x squared by in order to get to x to the 4th? Well, that's going to be an x squared. This becomes x to the 4th plus 2x cubed minus 3x squared. Don't forget that we're subtracting everything here. That leaves us with 2x cubes plus 7x squareds. I'm going to change colors for the next step. So next step is, what do we multiply x squared by in order to get to 2x cubed? Well, that's going to be a 2x. And then when I multiply all of the divisor by 2x, we get 2x cubed plus 4x squared minus 6x. Again, we're subtracting all of that. That's going to leave us with 3x squareds plus 6x's. Switch colors one more time. What do we multiply x squared by in order to get to 3x squared? That is positive 3. That'll leave us with 3x squareds plus 6x minus 9. Then we're subtracting all of that. And what we get is our remainder of positive 9. Sorry, I ran out of a little bit of room there. All right, so when I rewrite the function after performing the long division, let me create some space here. Our function looks like this: x squared plus 2x plus 3, and then the remainder, 9, over the original divisor, x squared plus 2x minus 3. All right, that'll help us figure out everything else. So the non-vertical asymptote then is just the quotient. That is y is equal to x squared plus 2x plus 3. So we've got a quadratic there that we've got to graph in order to get that parabolic asymptote. Then the intersection point between the non-vertical asymptote and the function, remember that comes from that remainder. Now, 9 can't be set equal to 0, and then there's no x to solve for. So there is no intersection point here. And then the last two pieces, as x approaches negative infinity, our function approaches the parabolic asymptote from above or below. We'll figure that out in just a minute. Same thing with positive infinity. Our function approaches that parabolic asymptote. The last thing we need to do is just figure out above and below. So we go to the whole entire remainder here. We're going to plug in a really negative number for x first. That leaves us with a positive on the top because 9 is just positive. And then x squared on the bottom. Any negative number squared is still positive. So we're going to be approaching this from above. And then same goes for when x approaches positive infinity. This whole remainder goes to a positive number. So again, we're approaching from above there. All right, I'm going to transfer all of this over to the template, and then we'll finish the sign chart, and then we'll go to graph. All right, so I've copied all of that information over. I kept those zeros with the stars next to them, and then I translated that into the sign chart. So I put all of our critical points into the sign chart. Those are the vertical asymptotes and the zeros. Made sure that I lined them up from smallest to greatest. And now I've got the intervals. We just need to figure out if our function is positive or negative on those intervals. So again, we have two double zeros. Those come from those factors in the numerator being raised to even powers. And I've got stars at those points, so -2 and 0. And I know that on the sign chart, our sign is not going to change around those two values because those were the values being raised to even powers. Everywhere else, the sign's going to alternate. So I just need to find the sign of our function from -infinity to -3, that first interval. So if I plug in a really negative number to our simplified function, on the top, we've got x to the 4th. We've got 4 x's on the top. That's our biggest degree. And on the bottom, we've got x squared. So any negative number raised to the power of 4 is positive, and then any negative number raised to the power of 2 is also positive. So in this case, on the interval -infinity to -3, our function is going to be positive. And then -3 is not special, so we're going to go to negative. Now -2, we don't change the sign, and neither do we change the sign at 0. And then 1, there's nothing special about 1, so we change the sign around 1. And there's our sign chart. The last thing I need is enough information to be able to graph that non-vertical asymptote accurately. So x squared plus 2x plus 3, I'm going to get that into vertex form so that I can actually graph this accurately. If you don't graph your parabola accurately on the test, you're not going to get full points. So we always want to make sure we have at least 5 points for the parabola. And that's also going to help us get the correct shape of our function. Okay, so vertex form here, again, I'm going to subtract 3 from both sides so that I can get everything with an x on one side, and then I'm going to complete the square. So in this case, to complete the square, I'm just going to add 1 to both sides, and so I'm left with y minus 2 is equal to x plus 1 squared. So the vertex here is the point -1, 2. And then we have a stretch of 1. A is 1. There's nothing in front of the x squared term. So let's graph everything. I have asked you guys to scale the x-axis by 1/2. So we're going to count by 1/2 along the x-axis. And then we're going to count by 1 still along the y because we've got that hole that we kind of need to fit there. So just kind of keep that in mind. If I've asked you to scale, you don't need to worry about writing anything on the graph itself. All right, so first up, we've got a hole at 2/64/5. So that's like almost 13. So just kind of estimate. Now 2 is going to be 4 along the x-axis because we're counting by half, and then up almost 13. About right there. We've got 2 zeros, add 0, 0, and -2, 0. Okay, again, remember we're scaling that x-axis there. And those are closed circles because they're defined. Our function's defined at those points. And then we've got 2 vertical asymptotes, one at -3 and one at +1. Asymptotes are always denoted by dotted lines. And then our y-intercept is already graphed. It's the same as the 0, as one of the zeros. And now I'm going to go down to that non-vertical asymptote. So I'm going to use vertex form. I'm going to plot the vertex and then use the stretch to get those other points that I need. So the vertex is at -1, 2. So that's this point here. Now I'm going to plot the points for the vertex with solid points, and then I'm just going to connect those dots with a dotted line to get our actual parabolic asymptote. Okay, stretch here is 1. So we're going to go right 1, up 1, left 1, up 1 to mirror that, right 2, up 4, and then I'm going to mirror that point as well, right 3, up 9, same thing, mirror that point to the left. And let's see, can I fit right 4 up 16? Doesn't quite fit, so that's okay. I've got enough points to give me a general idea of what the parabola is going to look like. Now remember that this is an asymptote, so I'm going to connect all those points with a dotted line here. Okay. Looks something like that. All right, there is no intersection point between the function and the non-vertical asymptote, so we've got all of our information. Now we actually just need to sketch the curve here, so I'm going to do that in a different color. I'm going to use our sign chart to do the rest. So on the interval negative infinity to negative 3, now remember we always follow asymptotes, even if they're quadratic and they look a little funky. So on the interval negative infinity to negative 3, we're positive, which means we need to be above the x-axis. And then also, because that interval includes an infinity, we need to look at the end behavior. As x approaches negative infinity, we are approaching that quadratic asymptote, that parabolic asymptote from above. So where are we positive and above the parabola on that interval? Well, it's up here in this space right here. So we're just going to build a function or a piece of our function that looks like that. We follow both that vertical asymptote and also the parabolic asymptote. And then on the next interval from negative 3 to negative 2, that's that vertical asymptote to the first 0 on the left. We're negative. So our function is going to come down like that, follow that vertical asymptote. And then from negative 2 to 0, we're still negative. So we're going to come up, touch that 0, and then we're coming back down and maintaining that negative sign value. And then from 0 to 1, we're still negative. So we're going to do kind of like the same thing. We've got this wobbly M looking shape. And then from 1 to infinity, we are positive, and then because that interval also includes infinity, we've got to look at the end behavior. We're above the parabolic asymptote. And we've got that hole there to kind of help us with the guide. So above the parabola, above the x-axis, we're going around here. Okay, got to go through that hole. Looks like that. All right, that is it. So you guys are going to finish up this handout. Make sure you're showing your work. If you want full credit, there should be a lot of work for these couple of problems. Email me if you guys have questions. I'll see you later.